On Earth, if you drop an apple, it falls to the ground. This is because of Earth's gravity. Gravity is a force that pulls objects towards each other. The bigger an object, the stronger its gravity. In space, things are different. Gravity doesn't disappear, but it is much weaker. This is called microgravity. Because gravity is weaker in space, objects don't fall to the ground like they do on Earth. Instead, they float. If you were to step outside a spacecraft, not recommended, you wouldn't plummet, you'd simply float alongside it. Imagine throwing a baseball straight ahead in space. What happens? On Earth, the ball would curve downward, and eventually hit the ground because of gravity. Gravity pulls everything towards the center of the Earth, giving objects weight and causing them to fall when thrown. In space, the ball would keep moving in a straight line forever, or until it bumped into something. This is called free fall. Without gravity to pull it down, the ball continues on its path indefinitely. Inside the International Space Station, astronauts experience microgravity. This means they are in a state of continuous free fall, creating a sensation of weightlessness. They float, and so do objects around them. Everyday activities become unique challenges in this environment. It's like a constant state of falling, but without ever hitting the ground. This unique condition allows for experiments that are impossible on Earth. Astronauts have conducted fascinating experiments in microgravity. These experiments help us understand fundamental scientific principles. For example, they've observed how water forms into perfect spheres. This happens because, without gravity, surface tension becomes the dominant force, and flames burn differently without gravity's pull. The absence of gravity affects the behavior of fire, leading to new insights into combustion. Sir Isaac Newton's laws of motion explain how objects move, not just on Earth, but also in the vast expanse of space. These laws hold true even in the vastness of space, where there is no air resistance or friction to slow things down. Newton's first law states that an object at rest stays at rest, and an object in motion stays in motion at the same speed and in the same direction unless acted upon by an unbalanced force. This is often referred to as the law of inertia. This explains why objects in space keep moving in a straight line unless something alters their path, such as gravitational forces from planets or collisions with other objects. His second law explains how force, mass, and acceleration are related. Force equals mass times acceleration. This means that the greater the mass of an object, the more force is needed to accelerate it. This helps us understand how much force is needed to move objects in space, which is crucial for spacecraft propulsion and maneuvering. Engineers use this principle to design engines that can effectively move spacecraft through the vacuum of space. Newton's third law states that for every action, there is an equal and opposite reaction. This is why when a rocket engine fires, it pushes the rocket forward. This is the principle behind how rockets launch into space, overcoming Earth's gravity to reach the stars. Understanding these laws is essential for space exploration and technology. Over time, we've left a lot of stuff in space. Old satellites, rocket parts, even tools dropped by astronauts. These items, once useful, now contribute to a growing problem. This is called space debris, and it's becoming a significant issue for our space activities. Because objects in space don't fall back to Earth like they do here, they remain in orbit indefinitely, creating a long-term clutter that can stay in orbit for many years, even decades. This debris poses a danger to active satellites and spacecraft, which are essential for communication, navigation, and research. Imagine a tiny fleck of paint hitting a spacecraft at super high speed. It could cause serious damage, potentially compromising missions. As we continue to explore and utilize space for various purposes, from scientific research to commercial ventures, it's crucial to address the issue of space debris. We must develop strategies to mitigate this growing threat. We need to find ways to clean up our cosmic neighborhood and prevent future collisions, ensuring the safety of our space assets. The future of space exploration depends on it. By tackling this issue now, we can pave the way for a safer and more sustainable use of space.